Here are two real jobs at the Relief Depot. Job A. A depot has 17 blankets and 14 water bottles. Each kit needs 3 blankets and 2 water bottles. What is the greatest number of complete kits? Job B. Relief meals ship in crates of 5, 10, or 20. What is the least number of crates to deliver exactly 95 meals? Do not solve them yet, just read them. Pause here for a moment. In each job, find the one thing you are pushing. Then find the one thing that stops you. So what does optimization actually mean? Take job A. You want as many kits as you can pack, so push the kit count up. Keep going until the supplies run out. They stop you. The best you can do is 5 kits, right at that wall. Now job B. You want as few crates as you can send, so pull the crate count down. Keep going until you would miss the 95 meals. That stops you. The best you can do is 6 crates. Each best answer sits right where the wall stops you. So read every one of these the same way. Circle the word that says greatest or least. That word is the objective. It is the one thing you push. Next, box the limit the answer must obey. In Job A, the supplies. In Job B, the exact count of meals. That is the constraint. It is the wall. A greatest answer sits at the last point under a ceiling. A least answer sits at the first point over a floor. The best answer is always where they meet. Now train your eye to spot the signal word. The most kits. That word most means you want the greatest. The fewest crates. That word fewest means you want the least. At least 6 of each. That phrase is not the goal. It is a wall you must respect. It is a constraint. This is the objective versus constraint rule. If a problem asks for the greatest or least of something, name the objective you push and the constraint that stops it, and the best answer sits at the edge where they meet. Look for the superlative word: greatest, least, most, smallest, at most, at least. It means you are optimizing. Learn, compete, and win. Visit competitivekids.org.